Bismillah ar-Rahman ar-Rahim, October 2009 and P4 and question number 4. So again, we have in this kind of question, we have ring and the particle attached with a string. So how we can deal this kind of questions? We mentioned 5 Newton weight is acting at this. So I'm going to make here 5 Newton. Okay. And then he mentioned clearly 30, 40, 50 given here. So we can find this angle theta1, this angle theta2 easily, and one angle 90-degree given here. So we can use SOHCAHTOA. And so what is in front of this is called opposite, and this is so opposite by hypotenuse. So if I find sine inverse, theta2 is equal to sine inverse 30 over 50. So I'm getting here theta2 is turned to be 38.869, or I can say 87, no problem at all. And what is this theta1? So simple, I can say theta1 is 180 minus both or 90 minus theta2. So no problem. I can tell directly, and that is turned to be 53.13 degree. So I got both. Now he's asking what here? If we read a statement, equilibrium given, okay. And here is a ring is given S, okay. And resolving forces on P. So our focus is on P. We don't care about S, okay. All right, make sure some people try to resolve F forces also, they try to mix up. No, full attention, we have to focus on P. And next part on S, so full focus on S, then I will not take P. Make sure there's a key point of this topic, this question. And find the tension in the longer string, but we are bound to find both. Get ready. So because these are not equal, and I discussed many times, repeat again, if these lengths are not equal, a ring is here, so this tension and this tension will be equal due to string can slip through it. But if this is not ring, bead or particle, so these tensions are different from each other. So same condition, we have particles. So this tension I call as a T2 and this tension I call as a T1. So I'm going to make this component. I think I'm going to make it longer and one this component. And one I'm going to make it here and one I'm going to make it here. And this is a T because this is a theta 2 match, because when two lines are parallel, this angle and this angle equal. So this I call as a T2 and cos a theta 2, which is 38.87. This is a T2 sine 38.87. This is a T1 and cos, because theta 1 is here, so cos 53.13. This is a T1 sine 53.13. Now, students, I can tell easily these two forces sum equal to 5 and this equal to that. So I can say here T1 cos 53.13 is equals to T2 cos 38.87. So this will go down. Basically, I need looking for T2. So I will make a T1 subject. This will go down. And when it goes down, so cos 38.87 divided by cos 53.13, and when it divides there, it will give me 1.2976 T2. This is a left and right. And now talk about upward equal to downwards. So I'm writing now here T1 sine 53.13 plus T2 sine 38.87 is equals to 5 newtons. So this value of T1 goes here. So it means this number will multiply with that, and I can write now here, put T1 value. What I can get it? I can get it, let me check it, times 2 sine 53.13. And when I check it, so because this number going to multiply with this, I'm getting 1.038. T2 must be there. and I'm going to close, I'm going to find it T2 common out. So this value and this value will divide 5. Look, I show you 5 over 1.038 and plus sine 38.87. So students, plus sine 38.87. When I get it, so 5 divided by this answer, I get T2 is equal to 3 newtons. So I got it here. So I got T2 is a 3 newtons, 3.00 something. So I got this one. So first part is completely over. Now, students, because he asking in the longer part, see, he asking longer string, which I got it, and longer string is T2. No need to find T1. If we want, if plug in simple here. Okay, let's talk about the other condition. He's saying magnitude of frictional force on S now. So my attention is totally on S now. For your sake of understanding, students, what is this? I call T2. My question, what is this? Also T2. Why, sir? Because they are balanced and they are equals to each other. So now I will not take I will part number 2 because this pull is this way due to this weight. So I will now when I talk about S ring, okay, I will take this force. So get ready, and this force is basically is a T2 value. So I'm going to start. Now I can bring attention only on the S particle. So have a look, please. This is S ring, and this force, as I found before, T2, and T2 is 3 newtons. You know it very well. And this angle we have how much? Theta 2 is 38.87. 38.87. Okay, what is this force, students? Our normal reaction. What is this ring, weight of the ring? And because pull is this way, so friction will be backwards, and it has a two components, one is this way and one this way, and this is a 38. So this I'm calling 3 cos 38.87. This I call 3 sine 38.87. And he asking what frictional force acting on the S. So actually friction force equal to that, so over. So I can say that F is equals to 3 cos 38.87, and that's it. So I can say here, let me check, this times 2 cos 38.87, and my answer is turned to be 2.337, 371, and 3SF is 2.34 newtons. So Alhamdulillah Rabbil Alameen, clear. Now part number next of same question, the coefficient friction is 0.75. Mu is given, find limiting equilibrium and find W. So we have to find out W. So R is equal to these two forces addition. So I'm writing here R is equals to W plus 3 sine 38.87. Okay, what is the formula we have, student? Basically, F is equals to mu R. And F is coming from top, this value, I'll take it with 2.3371, and mu value is what? Hold on, 0.75. So 0.75, and R value I'm writing W plus 3 sine 38.87. Now this will go down. So when divide by 0.75, I get here 3.1162, and W plus 3 sine 38.87. This will go and subtract, and going to finish the question, minus 3 times 2 sine 38.87, and this is my final answer. W come 1.23 newtons. I hope, and what he's asking for, find W, and W is given, you can see here, wait a minute, newtons, you see, newtons, so W newtons. So Alhamdulillah Rabbil Alameen, the concept of the question is completely over.